Now, the first part in creating any mechanical device is to design it. When we first designed and built a prototype, we were aiming for a side-by-side layout of the gears. However, in our final design, as you can see, we moved more towards a layered gear system in order to shorten the entire system and to shift gears much more efficiently. Once we had established our gear system, it was time to tackle the challenge of making the gears actually shift. For this, we chose to use pneumatic pistons. Pneumatic pistons use air pressure to force an arm out with high strength. Now, let's take a look at the build process. Now I'll briefly take you through the prototype build. This prototype uses a 269 motor and has a flat gear system. However, it did not include a reverse gear, which is why it needed to be changed and it needed to be updated. After redesigning the transmission from its predecessor, we finally felt that we were ready to build.
As I am the builder, I set out to work with creating a shell of metal that would become our transmission.
Here is the final product, and once it is built, it was time to program that sucker. To program the transmission, we used the program Robot C. We use RPM or revolutions per minute of the red box quadrature encoders to find out when we need to shift gears. That is, in essence, what makes this an automatic transmission. The fact that the shifting of the gears is caused once the RPM reaches its maximum amount of revolutions instead of the motor reaching a specific speed. In each gear, the RPM rises once it is shifted, and that is what gets us all the way up to 4th gear. An extra step we went was to code a VEX LCD display to show the RPM at all times.
Some specifications for our robot include one 269 motor, and our top speed is 0.85 miles per hour.
Other specifications include a length of 23 inches, a width of 13 inches, and a height of 9 inches. And we use one red box quadrature encoder on the transmission. Our two subsystems in the transmission include the gear system and the solenoid system. The gear system is now very efficient as it is a layered one. The gears shift almost flawlessly and it can shift into reverse on command. The solenoid system is very well laid out, as you can see, with nothing out of place and everything very neatly handled. As a whole, our system is very efficient and reliable. After numerous tests, it has proven its consistency. During the design process, our biggest challenge was creating a system to shift gears. Using pneumatic pistons was that best solution, and they were implemented beautifully. In retrospect, the VEX parts that we used worked loads better than we expected. In some other builds with VEX, the gears that had to mesh would click sometimes and they would catch. However, with this system, for some strange reason, they have meshed very well towards the end. And from our thinking process, we were able to create new ways to build and grow this machine. So thank you all very much for coming with me on this journey. And from Matt and Josh, we out. Peace.